Picture opening a browser window and seeing the Earth covered in live data. You can watch commercial satellites trace their orbits, monitor military aircraft coasting through international airspace, and look down at street-level traffic density, all in real time. You might assume a display with this level of surveillance belongs in a classified intelligence briefing. But this specific dashboard was coded in a standard web browser by a single former Google product manager over a long weekend. For centuries, cartography operated under a strict mechanical limitation. A map was a fixed drawing on a piece of paper, recording borders and roads exactly as they existed at the moment the ink dried. That constraint is gone. Instead of drawing static representations of history, developers are actively rendering a continuous, one-to-one digital twin of physical reality as it happens. We can only measure the weight of this omniscient power by manually building a digital twin ourselves, stacking it together layer by layer. By swapping a frozen historical document for a live three-dimensional rendering, a map becomes an active, functioning interface for the real world. The foundation of our digital twin is layer 1, geometry. We start with commercial satellites constantly orbiting the Earth, scanning the surface with optical sensors capable of resolving objects smaller than a single meter. Engines like the Google Maps platform take that massive influx of raw photography and stitch it together. They output photorealistic 3D tiles, effectively wrapping the globe in an incredibly accurate dimensional base mesh. Layer 2, telemetry, provides the vital signs. By plugging into open APIs, we pipe live movement onto our digital globe. Crowdsourced ADS-B data tracks military flights above, while OpenStreetMap networks spawn particle systems mimicking dense city traffic below. Because of modern web-based rendering libraries like Deck.gl and Cesium, you don't need a supercomputer to process this. A solo developer can layer tens of thousands of moving data points directly over a 3D city, right inside Chrome or Safari. Merging high-fidelity geometry with live public telemetry transitions the map into a real-time tracking engine. We know what the world looks like, and we know what is moving through it. Layer 3 is intelligence. This is where we apply geo-AI and building information modeling, highly detailed structural data of physical buildings, to our live telemetry. Platforms like Supermap run simulations before reality happens, calculating exactly how a flood wave travels down a river basin, or automatically reroute urban traffic around anomalies before gridlock sets in. But satellites and sensors have blind spots. Layer 4 is imagination. Researchers at World Labs, led by AI pioneer Fei-Fei Li, are creating what they call large world models to fill in the gaps. Their system, called Marble, uses generative artificial intelligence to take a single flat photograph and expand it outward. It constructs a fully navigable, three-dimensional virtual environment using Gaussian splats, essentially a dense cloud of colored points that accurately render light and geometry from any angle. Infusing the digital twin with predictive AI and generative environments creates a machine capable of constructing the future. Assembling all 4 layers, geometry, telemetry, intelligence, and imagination, creates a fully operational digital Earth. The multi-million-dollar barrier that once kept raw intelligence locked in government silos has been bypassed by standard browser code. Achieving this spatial awareness used to require the budget and infrastructure of legacy state institutions. Today, a domain expert can string together public APIs and rendering libraries to build the exact same operational worldview in a matter of days. But this democratized access introduces a severe friction point. When anyone can synthesize CCTV feeds, live orbital tracking, and generative AI into a single browser window, the line between public visibility and invasive surveillance becomes permanently blurred. Geography has transitioned into an active variable. We use these renders to code, manipulate,